So in resuming our exam 2 review, this question, again, this may not have been your question number 8. This is just the 8th question that I'm going over. We're asked to find an equation of a normal line to the graph of f of x equals x over 2x minus 3 at 1 comma f of 1. Okay, and then the way it's written, our multiple choice, I gave you our multiple choice answers here because it's a little strange the way it's written. So there's a couple things that are hard about this. One, anytime we're doing an equation of a line, we're going to start with y minus y1 equals m times x minus x1. Now that's not the form it's written in our answers, but it's still going to be the easiest form to start with. Okay, so we can find something first. We have one piece of information given to us off the bat for that equation of the line. What piece of information are we given?
What x is equal to?
That what x is equal to, right? And x is equal to 1. So I can fill in my x1 and we have x minus 1 there. Okay. Now, I think the next easiest thing to do is to figure out what f of 1 is, to figure out my y1. So I'm going to take that equation, f of x, and I'm going to plug in 1. So we're going to get f of 1 equals 1 over 2 times 1 minus 3, which is 1 over 2 minus 3, which is 1 over negative 1 or negative 1. Right? So that's our y1 value. That's going to go into the equation for y1. So we have y, and it's going to end up being plus 1. Okay, now the thing we're missing is m, and the m is a little bit strange on this one because it wants the equation of the normal line. If we were finding the equation of the tangent line, we would take the derivative and plug in 1. And actually, that is still what we're going to do, even though it's asking us to find the normal line. Does anyone remember what normal means?
The slope is going to be the negative reciprocal.
Exactly right. And why is that? What's a negative reciprocal slope? What would that mean graphically?
The perpendicular line.
It's perpendicular. So, right, if I have an equation and I have a tangent here at some point, all that a normal line is it's the perpendicular line to the tangent. It's got the same x1 and y1, but the thing that changes after you find your derivative and plug in 1 is that you need to negate it, so multiply by negative 1, and then flip it, so find the reciprocal, because a normal line means the perpendicular to the tangent line, okay? But everything else is the same, and so your approach is going to be the same. So now we have to take the derivative. This is quotient rule, so our derivative, I'm going to write down low, high, and then, oops, d low and d high. So our low, why is that moving so much? Our low is 2x minus 3. Our high is x. Our d low is 2. And then our d high is 1. So this is where our song comes in. Low d high minus high d low over low squared, and off you go. You're welcome to write it down if it helps you so you don't forget. I know it's maybe been a while since you did quotient rule. Most of you guys, if you remember that little rhyme, it helps you make sure you're setting this up correctly. Okay. One thing to be careful of, make sure the order of that numerator is correct, that you're not starting with high d low. And make sure you have subtraction in there. For product rule, it's a plus. For quotient rule, it's subtraction. So we should have 2x minus 3. I'm going to label this as f prime of x is equal to 2x minus 3 in parentheses times d high. D high is just 1, but I'll show it. Okay, you don't need to. It's fine if you don't. And then minus high, which is x, times d low, which is 2, over low squared, which is 2x minus 3 quantity squared. It's really easy to forget the squared there for some reason, so just be careful with that. It is really helpful if you just write down the little low d high thing first. You're just less likely to make a mistake. Okay, now we're going to simplify. So we have 2x minus 3 minus 2x over 2x minus 3 squared. You can't cancel out a 2x minus 3. Some of you try to do that. You can't simplify some things from the numerator and the denominator unless there's multiplication in that numerator. And since everything is addition or subtraction, we can simplify by combining like terms. We can get rid of that negative 2x and 2x. And so now we have negative 3 over 2x minus 3 squared. That is not what goes in for m. Some of you still get confused on that. In order to find our slope of our tangent line, and again, that's also not what's going to go in for m, but we need it. We are going to specifically find f prime of 1, meaning I'm going to plug 1 into this equation. We get -3 over 2 times 1, so 2 minus 3, and then that quantity is being squared. Right, so we end up getting -3 over -1 squared, which is just +1. So we get a -3. Okay, but that's not what's going to go in for our m. That is what f prime of 1 is. What is going to go in for our m?
The negative reciprocal.
The negative reciprocal. What's that in this case, Gus?
Positive 1/3.
Positive 1/3. Perfect. So since we got a -3, our m is equal to positive 1/3. So we negate it and we flip it, right? -3 is the same as -3 over 1. So the negative reciprocal is positive 1/3. Okay, so this is our equation of a tangent line, but this is multiple choice, and that answer is not available anywhere over there. Okay, and this is where students, I think, get pretty stuck. Like, you just did all this work, you know you did it right, you did quotient rule, you know what normal line means, you fixed all that stuff, but now you got to get it in the form that they provided in. And that's also a very common thing to happen on the AP exam. Like right now, there's no more calculus to do. All we have to do is some algebra, but that algebra can be challenging if you don't know good techniques. My suggestion on this one, you'll notice there's no fractions over there. So I'm going to first get rid of that fraction by multiplying both sides of the equation by 3. Okay, I'll show that down here. I'll move up a little bit. So I'm going to multiply both sides of that equation by 3. That's going to give me 3y plus 3 is equal to, and again, I'm just taking this equation and multiplying it by 3 on both sides. The 3 times the 1/3 is going to cancel out. And so everything else on the right side is just x minus 1. Okay, that already simplified it quite a bit, just recognizing, hey, I can get rid of that fraction since there's no fractions over there, and that will simplify my equation. The other thing you'll notice is all of the x's and y's are on the same side, but another thing you should notice is all of the x's are positive in all of those options. Okay, so these are kind of patterns that they're going to give you, but you have to recognize, because if I were to subtract everything to the left, makes it kind of harder to see which equation we're looking for, right? So I'm instead going to move that 3y to the right side, and I'm going to move my number to the left side because all of those examples have positive x's. So I'm going to subtract the 3y from both sides, and I'm going to add the 1 to both sides. So I'm going to get 4 is equal to x minus 3y, which is D. Those patterns, they're not obvious, but you're going to get better at looking for them when you get to this point in a problem. Okay, any questions on this one? Lots of steps here, but really it's not a hard calculus problem if you know quotient rule, right? So even though this problem might take a little bit of time, if you know, there's going to be problems that are very hard that you don't know how to do. So if you get to a problem like this and you're like, oh, quotient rule, I should skip it. I don't know, rethink that, because you're probably really good at quotient rule. And these numbers, you're plugging in 1 for stuff. Like, it's not hard algebra that we're really doing here. Okay, all right, let's go on to the next one. This one's a bit harder because there's an ln and an e, and you guys don't like those things. So we have let f of x equals x times ln x. The minimum value attained by f is. Here's where reading is really important. Okay, so we don't have a situation where we have a bounded function. Like, it's not saying find the minimum value from 1 to 5 or something like that, right? So we don't have to test endpoints. What we need to do is we need to take the derivative and figure out where it's changing from negative to positive, right? That's going to be our critical point. So first we got to take the derivative. So I'm going to set up my a and my b because this is product rule. It's really easy in a high stress situation like a test to forget product rule and just do like 1 times 1 over x. Just be very careful of that. So we have x times ln of x. My first function to go in for a is going to be the x. My b is going to be ln of x. Derivative of x is 1, derivative of ln of x, you need to know this, and some of you still just struggle with what this is 1 over x. That helps you with derivatives and it helps you with integrals if you can make that connection. Ln of x is 1 over x. Okay, And it's different if it was like ln of 5x minus 3, right? That's where you're really doing chain rule. So you do 1 over 5x minus 3 times 5. But since it's just ln x, it's just 1 over x. Okay, our f prime of x now, we're going to multiply these things together. We're going to get f prime of x is equal to x times 1 over x plus, don't forget, for product rule, it's a plus, 1 times ln x. So I'm just going to write that as ln x, which gives us, those x's are going to cancel out, 1 plus ln of x. So that's our f prime of x value, right? Now from here, what we're going to do is we're going to set this equal to 0 so that we can find critical points. And I'm just going to do that in the same step. So 0 equals 1 plus ln of x. I can subtract the 1 to both sides. And now to get rid of the ln, or the way that you're trying to think about this to solve what x would be, I like to exponentiate both sides. That's maybe what you learned in pre-calc, or you can rewrite it in that exponential form instead of in logarithmic form, and that kind of gets you to the same place. So this -1 equals ln x is the same as saying e to the -1 is equal to x. I just prefer thinking about it that way, right? Which means x equals 1 over e. Now, there's a 1 over e over here, which is why I think a lot of students miss this problem. Because it's not asking where is there a minimum value. It's asking what the minimum value is, okay? But there's an option on here that there's none. And so we have to be careful and figure out, well, is that a minimum or maybe it's a max and then there's none because we only have one critical point, okay? What I would do from here, since we probably don't know how to graph this, we probably don't know how to think about 1 plus ln of x and think about how that changes from negative to positive. Maybe you do. I mean, ln of x just looks like this, right? So 1 plus ln of x is just that shifted up. And what we found was we found a 0 at 1 over e, or e to the -1. So if you know how to graph that, and again, the thing I'm graphing is not the original function. The thing I'm graphing is f prime. If you know how to graph 1 plus ln of x, if you know your transformations, that ln of x looks like this graph, and all I did was shift it up 1, you can clearly see that 1 over e is a minimum. How do I know that? Why do I know based on that graph that, that 1 over e is a minimum? What tells me that?
It goes from negative to positive.
Exactly right, Ethan. It goes from negative to positive. So we're changing from negative to positive. So that tells me it's a minimum. But if you didn't know and you weren't sure how to graph that, one thing you can do is put it on a number line. You just have to be careful about the values you choose on that number line. So maybe even calling it e to the -1 is helpful. And now we just need to choose a value to the left or right, right? Now I can't choose 0 because that's going to cause it to be undefined. And I want to choose something helpful to think about how I can evaluate an ln. Does anyone have a value that they would maybe choose that's over in this region? So it can't be 0. What's a value you might choose? What's smaller than 1 over e, but is bigger than 0?
1 over e squared.
1 over e squared. That's exactly what I would do. So I would do like e to the -2, because that's going to be easy actually to evaluate in an ln function, right? Because if I'm trying to evaluate where f prime of x is equal to 1 plus ln of x, I want to pick stuff for x that's easy to think about. So if I choose f prime of e to the -2, I get 1 plus ln of e to the -2, which is 1 minus 2, which is -1. So that tells me this region is negative. Again, we can see that from the graph. If you know the graph, you're saving yourself a lot of time because you don't have to figure this out. And then similarly, another value we could choose for this region over here would just be something like e, right? E is bigger than 1 over e. And so we would do f prime of e. We would get 1 plus ln of e, which is 1 plus 1, which is 2, so a positive. So even if you don't know how to graph it, as long as you know values that would make sense to choose, you could do a number line. And then again, you're seeing it's going from negative value to positive value, which means it's a minimum. Okay. But again, that's not what this question is asking for. It's not asking us where is the minimum. It's asking what is the minimum. So common mistake is that students will take that 1 over e and plug it back into their f prime. They'll take that 1 over e and plug it in here. And then what are you going to get when you do that?
0.
You're going to get 0 because that's how we found it, right? That's the whole thing we just did. We set that equation equal to 0. So if I go back and plug it in, I'm just going to get 0. But they know some students are going to do that, and they put 0 as an option. So just be careful of that as well. What I actually need to do, and again, this is where the reading is so important. I need to go back to that original function, f of x is equal to x times ln of x. And that's where I need to plug in my 1 over e. And again, 1 over e is the same as e to the negative 1. So however it makes it easiest for you to think about that, 1 over e times ln of, and maybe it's easier to use both, like 1 over e and ln of e to the negative 1. Those are the same thing. Okay, e to the negative 1 is negative 1. So we get negative 1 over e, which is a. And again, it might not have been A on yours, and this might not have been question number 9, but that's how you would approach this problem. Okay, any questions on this one?
Ms. Toshner, I'm still kind of confused, like on the terminology at least, because I think when I read this one, I just saw like the is, and I thought like where is, like my mind just kind of jumped to that, and so that's maybe the mistake I made. But how would I tell like if this is like a what is versus a where is?
It would say is at. That's what it would say. That would be the one word difference. So the minimum value obtained by f is at, because that's a where location. The what is the minimum value. And that's such a small difference, right? Like if it asks you what is the minimum value, I think you guys are clear that that's the output. If it says where is the minimum value, you're clear that that's like the x coordinate or the critical point. The way this is worded is harder. And the difference is just that it's saying the minimum value is, that is the minimum value. It would have to ask the minimum value is attained by f at, if it was looking for where that occurred. So remember, the where is the x coordinate. The what is the minimum value? The minimum value attained is going to be the output. And again, like this is super common. They're going to put the critical point as an option, because they know students are going to misread it. They're going to do everything right, and then they're going to get a wrong answer. I think College Board is just a bunch of trolls. They're just a bunch of people who are like, ha, 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 how can I mess with calculus students who know everything, how to do this problem, and then still get wrong answers? Again, that's why it's, certain percentages are pretty low to get high grades. Great question, though. Any other questions? All right, let's go on to the next one. Got 2 more that we're going to do. Ooh, this one was a doozy. And it's not that bad, but this requires knowledge of second fundamental theorem of calculus. I think we did some videos on that. I'm pretty sure they're on YouTube. Again, you can just look this up if you get confused. I would write down g of x, capital G of x is equal to, we have the integral from 0 to 2x of cosine of t squared dt. And then it's asking us to find g prime of the square root of pi. Now, some of you who don't know how to do your u sub have come up with pretend ways to do u sub by like dividing by the derivative. And then that doesn't work on this problem. U sub actually fails on this problem. You cannot take that integral. So if you're doing this like quick way to do u sub, you're getting a totally wrong answer for your integral. And then you're trying to evaluate it and plug stuff in, and you're just getting a totally wrong answer. And that wrong answer is going to be an option, because they know students are going to do that, which is why I have said you need to practice your u sub. If you tried to do u substitution here, the only thing that you could pick would be u is equal to t squared. And the reason this fails is because you'd get 2t dt. And you cannot divide over a variable for u sub. So I can't have 1 over 2t du. I can't divide over a variable, and I can't have a mixture of u's and t's. It doesn't make sense. So the u sub fails. Luckily, it's not actually asking us to find the integral. It's asking us to find the derivative of the integral. So again, I would write this down. That's second fundamental theorem of calculus. What it wants us to do first is to find g prime of x, right? Eventually it wants us to find g prime of square root of pi, but we're going to first find g prime of x. Meaning I'm going to, let me move this over to the left a little bit actually. G prime of x means we're going to do the derivative with respect to x of this integral. So 0 to 2x of cosine of t squared dt. If you can write this first step, it should make it more obvious that that's second FTC, right? You're taking a derivative of an integral. Does anyone know how we approach this? Does anyone remember?
Don't you just plug the x part into the t?
That's most of it. Okay, so I'm going to take my bound. I'm going to start with my top bound and I'm going to plug it into the t. The integral and the dt totally goes away. So I'm going to get cosine of, instead of t squared, it's going to be a 2x that's being squared. It's going in for the t, right? It's not 2x squared, it's quantity 2x squared because that's going to go in for your t. But then there's something else I need to do. Does anyone remember what else I need to do here? It's not just plugging in the bound.
Oh,
You have to multiply it by the derivative.
You have to multiply it by the derivative of the bound, right? So the derivative of the bound means I'm going to multiply it by 2. Now you can also plug in the bottom bound. You can do the subtraction there. Some guys do this, but then they forget what else you have to do. So if I plugged in the bottom bound, I get cosine of 0 squared, right? But I need to multiply by the derivative of the bottom bound as well. So I'm going to multiply it by 0 because that's the derivative of 0. So that second term entirely goes away. So what I have left for g prime of x is cosine of, and I'm just going to simplify that now. That's the same as 4x squared times 2. And we can put that 2 out in front or you can put it at the end. It doesn't really matter, right? So 2 times cosine of 4x squared. So you're not actually taking an integral. You're using second FTC, meaning you're plugging in the top bound in for the variable, right? Integral and dt goes away. But don't forget to multiply by the derivative of the bound. And you're doing that into the top and the bottom. If the bottom is a constant, then you're always just going to multiply by 0. But the bottom is not always a constant. So just be careful of that. Okay, finally, the question's asking us to evaluate g prime of square root of pi. Mean I'm going to take this function and plug that in. So we're going to get 4 times the square root of pi, quantity squared. So now we have trig also on top of this, which it can be challenging, but it's really just unit circle stuff. So make sure you go back and watch some unit circle videos if you need help on that. We can simplify this down to 2 cosine of square root of pi squared is just pi. So we get 4 pi. Got to be able to think about where that is. So here we have 0, pi, 2 pi. It's going around once through the circle. All you're doing to get to 4 pi is you're going around a second time, right? So this would be like 3 pi and then 4 pi. It's a coterminal angle to 2 pi. So you're thinking about what's cosine over here? Cosine over here is the x coordinate over there. So cosine of 0 or cosine of 2 pi or cosine of 4 pi all are equal to the value 1 because it's the x coordinate at that spot. So you just need to know where that spot is. Okay, so we get 2 times 1, which is just 2. I'm glad we went over this one just because second FTC, it does show up very frequently all over the exam. It's not too hard, but again, you can make mistakes if you try to do like that cheat U-sub method, or if you just don't understand, you need to multiply by the derivative of the bounds. Those are common mistakes students make. Any questions on this one? Any questions? Good to review that one. Remember, first FTC works a little bit differently. Just while we're on this, before we get to that next one, first FTC, just in case you're like, oh, what was the other one? Because that's second FTC. First FTC is when I have an integral from a to b from any bounds. Those bounds could have variables or not, just any bounds. But instead of taking the derivative of f of x, or the integral, excuse me, of f of x, we're taking the integral of f prime of x dx. So this time the derivative is inside of the integral. Okay, it's different. It's second FTC if you're taking a derivative of an integral. First FTC means I'm taking an integral of a derivative. And what I get here is I get f, whatever the actual integral of that is, of b minus f of a. This is the one that you guys knew how to do before we even started talking about it. Like if I gave you from 1 to 2 the integral of x cubed dx, you know you don't just plug in 2 and 1 into that. You first have to take the antiderivative, right? So you would get like an x to the 4th over 4. And then you would plug in the top bound and plug in the bottom bound. Oops, over 4. That's all first FTC is, right? And they can write that in different ways. Like sometimes we've seen first FTC when it's like v of t dt from 3 to 5 or something. And then the antiderivative of v of t is x of t. So you get like x of 5 minus x of 3. This is all first FTC. Second FTC means you're taking a derivative of an integral. What you're doing there is you're not actually taking an integral. You're plugging in the top bound, multiplying by the derivative of the top bound, subtract, plugging in the bottom bound, multiply by the derivative of the bottom bound. Okay, that was just a quick refresher on those topics. We have one more that we're going to go through. Are there any questions on first or second FTC before we move on? I think you guys are feeling better about that. Just always helpful to do a quick review. Again, you can do that for yourself. Use Princeton Review, use Barron's, use YouTube, Khan Academy, whatever is helpful for you. Okay, next problem. The approximate value of y equals square root of 3 plus e to the x at x equals 0.08 obtained from the tangent to the graph at x equals 0 is. So the approximate value of, and I would write down y equals, so y equals 3 plus e to the x at x equals 0.08 obtained from the tangent to the graph at x equals 0 is. This is where we're looking for those approximations. And you guys might remember there's some crazy long equation that they're going to use in your textbook that has like a delta x and all this kind of stuff. You don't need that. You know what you need? You need the equation of a tangent line. That's all you need to do. So I'm going to start out by writing y minus y1 equals m times x minus x1. We are not going to start with the 0.08. We are going to write an equation of a line using that function, y equals square root of 3 plus e to the x, and I'm going to rewrite that as 3 plus e to the x to the 1/2. We're going to take that equation and we're going to evaluate it at 0. And we're going to come up with the equation of the tangent line for that function at 0. Because it says obtained from the tangent to the graph at x equals 0. That means I just need the equation of the tangent line at x equals 0. Okay, so I need 3 things for that. I have one already. I have x1, so I can plug that in. We're going to get x minus 0. You don't really need to write the minus 0. I just want to clarify that that's how we're getting this. And it'll be good to have in your notes to see where all these values came from. Okay, we also need y of 0, right? That's going to go in for our y1. So that's the same as square root of 3 plus e to the 0. Be careful, e to the 0 is not 0. It's a really common mistake for guys to make. E to the 0 is 1. So we get square root of 4, which is not plus or minus, right? If we're starting with the square root, it's just the plus. So square root of 4 is 2. So that's going to go in for my y1. And now I need to find m. So to find m, we're going to take the derivative. We're going to get y prime is equal to, now we need chain rule, right? So my outside function is something to the 1/2. So we're going to get 1/2 that something to the negative 1/2. But you cannot forget the chain. You need to multiply by the derivative of the inside function. The derivative of 3 is just 0. The derivative of e to the x is e to the x. The way that's written is pretty hard to think about and evaluate. So I would rewrite this so it's a little easier to evaluate. So we're multiplying by an e to the x, so that e to the x is going to be in the numerator. In the denominator, since I have that 1/2, I'm going to just call that a 2 in the denominator. And then I have a square root of 3 plus e to the x. It's not essential that you do this, but I think it makes it easier to not make mistakes. Okay, and now we're trying to evaluate that y prime at 0. So I'm going to plug in 0 for each of those things. We get e to 0 over 2 times the square root of 3 plus e to the 0. E to the 0 is 1 over 2 times Square root of 4, so 2 times 2. So we get positive 1/4. Okay, that's just a chain rule with some e's in it. Make sure you know how to do that derivative of e to the x. Derivative of e to the x is e to the x times the derivative of that exponent, which in this case is just 1. So we get a 1/4 going in for our m. So that's this part. We found the tangent to the graph at x equals 0. That's what we just did. That's this y minus 2 equals 1/4 times x minus 0. Now what we need to do is we need to use that equation in order to approximate what it would be if it was 0.08. So how do I do that? What would be next?
Plug in 0.08 into where you have x on your tangent line.
Perfect, exactly right. We're going to plug in 0.08 into this equation. So we get y minus 2 is equal to 1/4 times 0.08 minus 0. Now, there's easier ways and harder ways to do this. Some of you are going to have different preferences for how you do this. I like to make things fractions because I think it's easier to think about than these decimals. So 0.08 is the same as 1/4 times 8 over 100. I just think it's easier, even if the final answer is a decimal, to write it like this in order to think about those values, to think about that division, to think about what's happening. Okay, and we're going to get y is equal to that plus 2 if I move the 2 to the other side, right? I can cross cancel the 8 and the 4, so that's going to give me a 2 on top, so 2 over 100 plus 2. I think the final answer was a decimal, but this just means 2.02, right? 2 over 100. I prefer that way seems like the most obvious to me, but again, you could leave it as decimals the whole time. 0.08 divided by 4 is 0.02, right? And then you're just adding 2 to that. There's no right way to do that one, whatever works for you. Okay, any questions on this problem or how to approach it? This, again, that approximate value thing, if you see that word approximate, you usually see that in a couple places, usually a problem like this, or they'll say like approximate the area and it's like a Riemann sum. Those are kind of the two big places you're going to see that word approximate. All you have to do is an equation of a tangent line. Now, if you had a calculator on this and you just type that into a calculator, you actually won't get this answer. So it doesn't help you. Like if this question is in the calculator section, sometimes I've seen them do that. So students just try to evaluate by plugging it in. They're like, I don't know, I'll guess the one that's closest. It's not always the right answer. Okay, so just be very cautious of that. That was the last big problem I wanted to go over from your exam. Do you guys have any questions?